Hello everyone, thanks for joining the session live today or to those watching on our YouTube channel. My name is Manu Agarwal. I am a senior engineer here at Arup. I will be delivering today's topic of LS-DYNA submission and checking using Oasys PRIMER. I will be describing some tools in Oasys PRIMER to perform LS-DYNA submission and also for checking of LS-DYNA outputs. For this, I will be using the latest release Oasys Software Suite version 20.2. Before we begin, here is a brief outline of this session today. After the brief introductions to the Oasys team and Oasys product suite, I will be showcasing the LS-DYNA submission process from within the Oasys Primer. Then I will be talking about the checking of LS-DYNA output files, load and contact profiling, and MPP decompositions from within Primer. During the course of today's session, I will also demonstrate certain aspects of pre-post integration of Oasys Suite programs. Just a little about us. Oasys Limited is the software house of Arup. We produce the Oasys software, which is a pre and post-processing software designed especially to work with LS-DYNA. We also distribute LS-DYNA in the UK, India, and China, and we have over 30 years of experience of working with the developers of LS-DYNA. We also provide LS-DYNA support to clients around the world, which helps us develop a deep knowledge of LS-DYNA and understand the trends in its usage as well as the trends in the CAE market. Developed specifically for LS-DYNA, the Oasys suite is at the leading edge of pre and post-processing software and is used worldwide by many of the largest LS-DYNA customers. You can prepare a model in Oasys Primer, then analyze the model in LS-DYNA, then visualize and process your simulation results in dtplot and THIS, and finally generate your simulation report in the reporter program. The LS-DYNA simulation can be triggered, and also all of the Oasys programs can be launched from within the Oasys shell. Oasys Primer is a specialized preprocessor used only for the LS-DYNA models. Primer's modeling tools and comprehensive error checking can reduce the preparation and debugging time. Primer is fully compatible with the latest versions of LS-DYNA, so no information is lost when reading or writing out the model data. Primer's model management tools allow the CAE team to work in parallel on different components of the same model. Because of Primer's robustness and depth of understanding of the LS-DYNA data, users trust the Primer to work on their complex models without corrupting or losing any data. When we speak about checking of a LS-DYNA model, we can split this process into four major stages. First, you would be preparing your model in a preprocessor. Then you would perform the initial checks on the model. This is also usually done in a preprocessor. Then you would perform LS-DYNA simulation on your model. And while the model is getting run in LS-DYNA, you perform some checking as well. This could include model initialization checks, model load balancing, etc. Then you could also perform some analysis after the simulation is run completely. This is where you review the simulation behavior as well as interrogate the XY data. This last stage of model checking is mostly done in a post-processor, but there are also tools in Primer preprocessor to review the simulation output files. During each of these stages, you would want that appropriate checks are performed and you would want to ensure that the right model quality is achieved. Today we are going to talk about how you can perform the LS-DYNA simulation of your model in Primer and how you can view and analyze the LS-DYNA simulation outputs in Primer. This is, as mentioned before, is done in order to achieve a better quality of model and LS-DYNA simulation results. The common procedure for running large models in LS-DYNA is this. Your model is written out from Primer. Then the model files are potentially transferred from a local disk to your HPC and cloud provider. Then the results and data are transferred back, which will likely lead to model fixes, design changes, and iterations. Sometimes this whole process is time consuming for a particular task in hand. It's often useful to use the power of LS-DYNA to carry out smaller tasks, such as initializing and checking your model, or checking that the output LS-DYNA produces is what you're expecting. Being able to run LS-DYNA quickly and directly from Primer would help to streamline these type of processes. As mentioned before, Oasys Shell is the primary tool in the Oasys suite to perform LS-DYNA simulations. The shell gives you an easy access to all the various options available when submitting a LS-DYNA run. Oasys Shell executes a command that can be used for triggering LS-DYNA to fire LS-DYNA jobs. To aid the model preparation and checking processes and carry them out in the fastest and most efficient way, we have introduced a tool to allow direct submission to LS-DYNA from within the primer. This tool uses the power of Oasys Shell, a dedicated LS-DYNA submission tool in Oasys. This tool allows you to submit a model easily into LS-DYNA directly from within the primer. The model can be submitted locally or onto a remote machine or cluster. This functionality integrates with another powerful tool in Primer that performs checking on LS-DYNA output files. With this incorporated into Primer functionality, initializing and checking of your models becomes a quick and painless process. As well as speeding up the submission process, this functionality allows easy initialization and model checking with a few clicks. This tool can be accessed by clicking the Submit button in the Model Dock panel to perform LS-DYNA runs from within the primer. The model submission can happen on a local or on a remote machine. A local machine is the same Windows or Linux machine from where the primer session is launched. The remote machine is a Linux machine on a network where the LS-DYNA is configured to run. You can also monitor the progress of online or real-time LS-DYNA runs on a local machine. The model file that will be submitted to LS-DYNA can be chosen from the menu next to the Model Selector button. You can choose to rewrite the models file before the LS-DYNA submission or use an existing keyword file for the submission. The keyword file for the LS-DYNA submission is picked up from the submit directory. This is also the same folder location where the LS-DYNA outputs gets written out. Oasys Primer allows reading of binary formatted or compressed keyword files. In such scenarios, you will always have to rewrite the keyword models in ASCII format. This is because LS-DYNA cannot identify these binary and compressed keyword formats. Submission options define the LS-DYNA settings that are required to run the model on the specified machine. You can choose to run the SMP or MPP simulation runs in single or double precision LS-DYNA. You can choose any version of LS-DYNA up to the latest release version of the program. The executables for the latest and stable release of LS-DYNA can be picked up from the Oasys website. If you choose to run MPP simulations, then you would need to specify the type of MPI libraries that you want to use. The Oasys DYNA website also gives out the frequently used Intel MPI library installations. Of course, it goes without saying that you will always need a valid LS-DYNA license to perform LS-DYNA runs on your models. You can choose to perform the LS-DYNA simulations in various submission type modes as given in this menu here. You can also specify a variety of LS-DYNA options in this panel. This is a snapshot from the LS-DYNA manual. This gives out the execution syntax for running LS-DYNA and also various input and output options. Most importantly, you would need to specify the number of CPUs or the number of LS-DYNA cores that you would want your simulation to run with. The other LS-DYNA options can be specified in this tool in the additional panels. Setting all these options for LS-DYNA executable types, executable paths, various input-output options, this might become quite cumbersome. Also, it would be quite stressful to set these options every time you want to perform a LS-DYNA simulation, isn't it? For this reason, we have provided a facility to save all the options specified in the submission tool panel. The options can be saved under the unique submission bookmark name. The user can add, edit, remove a submission bookmark by pressing the relevant buttons. The submission bookmarks are saved in the primer settings file by pressing the Save Settings button at the top of the panel. Easy, isn't it? Now we are going to perform a quick demonstration of LS-DYNA submission tool on a simple crush tube model in Oasys Primer. We are going to perform a MPP single precision with IMPI MPI type on a local Windows machine using the currently loaded keyword file. We have specified the LS-DYNA and installed MPI executables, and we specify the number of CPUs to run the job as 8. After we submit the job, the LS-DYNA job monitor will monitor the recently submitted job on the local Windows machine. The job has been terminated normally, and the DTHSP file can be launched from this job monitor tool. To perform easy submission next time, we have saved the current options under a unique submission bookmark name. You can also review the simulation results in the Oasys post-processor ggplot via the integrated pre-post session. The views for both the models in both the programs are synced, and this is the animation of the simulation. After your LS-DYNA simulation is run, whether you have achieved normal termination or error termination, you might have to go through debugging mode and run some checks to debug the simulation of your model. Sometimes your model might run very quickly, or your simulation might take more than a day to get completed. A lot of information can be debugged from the OTF or DTHSP files and the message files that are written out by LS-DYNA automatically on completion of the model simulation. It is here that you can fetch a lot of warnings and errors that occur while running your simulation. Now, these files can be quite bulky and contain a lot of information. The amount of information generated by LS-DYNA also depends on the number of cores that you run your model on. This is because LS-DYNA generates one message file per core you run your simulation on. So sifting through these files is not always easy. Now, though Primer is a preprocessor, but it can also be used for post-processing checks. And there are tools in Oasys Primer to help you with that. And this is what we are going to talk about in the next section of this webinar. Most of you will be familiar with the DTHSP or OTF files. To check if the run has terminated normally and how long it took. Out of other items that you can consider in terms of the model quality is how long did the simulation take to run? Or in other terms, what is the efficiency of your model? Apart from the model size, it also depends on the number of cores you run your model on. So it is useful to understand what LS-DYNA is doing behind the scenes during actual simulation and where it is spending most of its time. Whether it is spending an unusual amount of time in context or on element processing. Now this information generally sits in the OTF files. You can find the timing info in the table near the end of the file, which shows the breakdown of the analysis on different tasks. The timing information here gives the list of items spent on each of the activities that LS-DYNA is performing during the model runs. The timing information is given in terms of the CPU seconds or percentages. This is something that you need to look out for and use this as a measure to benchmark the quality of the model. Also, if your model runs on multiple cores, the LS-DYNA gives out multiple message files with similar timing informations. So it is going to be harder to make sense of all this information. If the analysis is done using MPP, message files, contact, and load profile CSV files are outputted by default. What these files output is the summary of the processor load balance for the entire job run. And this is quite useful to figure out the processor load balance across all the cores on which the LS-DYNA simulation is run. It does this in terms of element formulations like solids, shells, thick shells, or beams. It does it in terms of time steps, contacts, and also rigid bodies. Keys to efficient parallel processing is having an evenly distributed workload across all processors. If one core is assigned a domain too small, then at certain points in each time step cycle, the core will be idle, waiting for other cores to finish their calculations. And the process of assigning group of elements to a particular processor is called decomposition. Now there are several options for partitioning the LS-DYNA elements. By default, LS-DYNA uses a recursive coordinate bisection method. This divides the model into two boxes along the longest dimension, and then again until the number of the domains equal to the number of processors the analysis is set to run on. There are certain control MPP cards that you can use to request this balancing information. When you do this, the LS-DYNA dishes out a decomp_parts.scs file. The primer can read this file to showcase the load balancing across the CPUs. In a short while, we'll take a look at the primer functionality that will use the highlighted control MPP keywords to induce decomposition while initializing a LS-DYNA model from within primer. Because the domain decomposition can have a large influence on how quickly the model is solved, the user has some control over how this calculation is decomposed and how it is run. Certain star control MPP cards can also be used to improve efficiency of your run times. Now we will take a look at the LS-DYNA output files reader in Oasys Primer. This functionality can be accessed by clicking the LS-DYNA button under the model check, which displays the Read DYNA window. Using this tool, it is possible to interrogate the standard output text files from LS-DYNA simulation for the following: errors and warnings, load and contact profiles, and message profiles, and decomposition on CPUs. The entities associated to the above can be displayed with the entities associated within the primer model. Reading the LS-DYNA output error files is most useful when the corresponding model is also loaded in the Oasys Primer. This is because the entities associated with the errors and warnings can be located and manipulated inside Oasys Primer. Though With the pre-post integrated sessions of Oasys Primer and Oasys ggplot programs, it is also possible to interrogate the LS-DYNA simulation outputs even without loading an actual model keyword file in Oasys Primer. You can either initialize the model in LS-DYNA and interrogate the LS-DYNA results, or directly load an existing set of LS-DYNA results. If you wish to initialize the model from within the primer gives out an option to run the LS-DYNA simulation with the mcheck option as well. For the decomposition, you can specify the number of processors to however many CPUs that you want to test the decomposition on. For example, you may want to run the HPC with 16 CPUs as a standard, but first want to check how this model will be decomposed in the local LS-DYNA. So while we are not running the LS-DYNA model locally on 16 CPUs, but setting this numproc value to 16 tells LS-DYNA to carry out the decomposition over 16 CPUs so you can visualize the results accordingly. To facilitate this, the Oasys Primer adds these three star control MPP keywords in the model before sending it for LS-DYNA simulation. The LS-DYNA job monitor also tells the primer when the job submission is finished. So you can also open the results directly from the job monitor panel as well. After the LS-DYNA directory is populated, these output files will be listed and automatically selected for viewing in the tree view. Log files like OTF, DTHSP or message files, contact load profile files with extensions .csv and .xy, and decomposition files, the file names with extensions .ses. Once the apply button has been pressed, the primer will open the DYNA output tree viewer in error mode, and this will display all the errors and warnings associated with that model. The LS-DYNA output reader functionality relies on an XML file to interpret the errors, warnings, and termination messages and other items that are printed in the LS-DYNA produced output files. This XML file is named DYNA output reader.xml, and this file is shipped along with the Oasys installation and can be located in the installation folders. It contains a list of all the errors, warnings, and termination messages produced by LS-DYNA together with the corresponding entity in primer or entities to which they refer to. If an error, warning, or termination message is found which does not have an entity associated with it yet, the XML file can be edited in a text editor accordingly. You can also contact Oasys Limited support channels if such a situation occurs so that the XML can be updated. Since the XML file is not bound to any particular version of Oasys Primer, new and improved versions can be distributed between different software releases. With this tool, you can read the standard output files produced upon initialization, and Primer will allow you to interactively visualize and investigate that data. The first part of this tool relates to errors and warnings in your model. The panel gives out the information on whether the LS-DYNA job simulation was successful or not. Here you can see the normal and error termination messages in the top of the panel. The errors and warnings produced by LS-DYNA are captured and presented in an interactive tree format. You can easily visualize and fix the entities referenced in those messages. In the error tree mode, the branches can be expanded to view the first level that gives out the generalized version of the error or warning messages. The second level gives the entity types to which the errors or warnings pertain. The third level gives out the entity labels referred to by errors or warnings. The item mode In item mode, the tree branches can be expanded to view the first level entity types that have errors or warnings associated with them. At the second level, the branches can be expanded to list the entity labels that are referred to by one or more errors or warnings. At the third level, gives the shortened form of each specific warning pertaining to that particular entity. Hovering above any of the shortened messages will display the full text message from the OTF or message files. Right-clicking the selection brings up the pop-up menu for that selection. Here the selection can be sketched, deleted, and viewed in different ways. Users can also edit the entry via the edit panel or the keyword editor, or even look at the cross-references for that entity within the model using the cross-reference viewer panel. The clipboard functions are also available. The pop-up go-to time will change the state display time in an integrated DTplot session. If an integrated DTplot session is not already running, a new DTplot session will be started. Next, you can view the information on how LS-DYNA is separating its calculations across multiple CPUs. DYNA Output Viewer can read the load profile, contact profile, and message profile files. This is useful to investigate which element formulations and contacts are most expensive and what changes you can make to improve the efficiency and load balance of your model. You can easily investigate the entities, processes, and calculations leading to your analysis runtime. You can also understand how these processes are spread across CPUs in MPP runs. Also, in particular, you can investigate the effect of contacts in your analysis. You can also visualize how your model is decomposed across the CPUs. LS-DYNA Output Viewer can read the decomposition output messages that are given out by LS-DYNA simulation. In this panel, the create assemblies will create an assembly for each CPU containing all the elements that are processed by the CPU after decomposition. Show assembly will show the part tree in assembly mode so you can easily visualize the new assemblies. The color elements will change the color of the elements in the model according to how the model was decomposed by LS-DYNA. Here you can see the decomposition of a front crash model with 16 CPUs. You can also visualize this decomposition information in Oasys ggplot via the integrated pre-post session. Alternatively, you can also write out the properties files from within the Oasys primer and read it back in the ggplot, along with the PTF files to visualize the decomposition groups. The decomposition colors can also be retrieved using a JavaScript that is released along with the Oasys suite. Now we will take a look at a demonstration for launching the output tree viewer panel by performing initialization in LS-DYNA from within the primer. Here we have chosen the option to run the simulation for 10 cycles and also designated 16 CPUs to perform decomposition. Here, as explained before, the number of CPUs to run the simulation does not need to be same as the number of CPUs designated for decomposition. Inside the submission panel, we first specify the submit directory to write out the model file and also the LS-DYNA outputs. We will use the submission bookmark that we had saved in the previous demo. So now we are running the single precision MPP LS-DYNA simulation with 8 CPUs. After the model is submitted for simulation, the primer job monitor will track the model analysis. Here you can see the primer is giving out the simulation status for the job run in the previous demo as well. This is because we had saved the job information in the bookmarks file. Once the simulation is completed, you can directly open the simulation results from within this job monitor panel. So now these are the files that are outputted by LS-DYNA, and now these files can be read within the primer. The error tree panel shows that we have achieved normal termination with no errors but a few warnings. By hovering over the warning messages, you can view the full text of the message as is given out in the log files. LS-DYNA also prints out the list of elements with smallest time steps. This is used to figure out what entities are driving your time step criterion in the model. So if your model is taking a particularly long time to run, you can go ahead and investigate that further. With the item mode in the error tree, you can showcase what type of elements are coming with least time steps. The show file option shows the messages in each of the particular log files. With the load profile panel, you can view the load balancing for different type of entities like elements, contexts, rigid bodies, etc. By hovering above the bar in the graph, the bar gets highlighted and the following information of the highlighted category in the red boxes above is given out. The first box shows the processor ID, the second box shows the number of entities, the third box gives out the type of entity, and the fourth box gives the cost information for that entity. You can also isolate the particular type of entity in the graph. Also, you can view multiple entities from multiple CPUs with the only multiple right click option. You can go back to the original view with the auto center option. Now we have come to the contact profile panel, which gives out the similar information like load profiles but with contexts. The panel gives you an option to exclude the no cost and groupable contacts from the graph. Here you can see a single contact from the barrier is processed only with CPU number 1. So this is your load imbalance. Inside the message profile graph, you can view different processes of LS-DYNA simulation in terms of the CPU or clock values and percentages. With the control key on the keyboard and the middle mouse button, you can drag the graph to filter out the range of the graph and get better visualization for certain processes. So this is the range in the graph. You can go back to the default view with the auto center option. Inside the decomposition panel, you can split the model into 16 different element groups and color these groups. This is similar to what we had already discussed a short while ago. While explaining the LS-DYNA submission of keyword models from within the Oasys primer, I had also mentioned that we can also perform remote submission of keyword models into LS-DYNA that sits on remote cluster machines. This can be done from the same tool panel that we have looked before. This is particularly useful where you do not have sufficient LS-DYNA licenses to simulate the large models that you might want to work with. I recently performed a LS-DYNA positioning analysis on this Thumbs HBM model and run it on the Arup Linux cluster. This Thumbs model is received courtesy of Toyota Corporation. But is running the analysis on the remote machines enough? You would certainly want to make use of the powerful LS-DYNA output reader on your local Oasys primer to analyze the simulation results, isn't it? So I had done the same, but how did I fetch the large simulation files from the cluster folders? For this, I used another powerful feature inside Oasys called JavaScripts. As you might know, JavaScript is implemented as an application programming interface within the primer. And this feature provides a range of automation functions. So using the JavaScript class, you can fetch any data from any machine onto your network onto your local machine. You can write a customized JavaScript function to fetch the files from a network machine and run that script using Primer. But even though the files are in zipped format, the size of the LS-DYNA outputs might be substantial. And since it might take reasonable amount of time to carry these large simulation files onto the local machine, I decided to use the batch mode primer to run this JavaScript. This can be done using the Oasys shell. Oasys shell can be used to launch Primer and other Oasys programs in batch or GUI mode and run these programs with multiple command line options like options to run JavaScripts. And since the LS-DYNA output checker tool in Primer can also read the compressed file format files, you can quickly read these outputs in the Primer. In the interest of time, I'm not going to go through the complete demonstration of remote submission of keyword models onto a remote cluster machine from within the Primer. You can, though, know more about the remote submissions, JavaScripts in Primer, and the shell from the various tutorial videos on our YouTube channel. To get more understanding of the tools that we have discussed so far, you can go into the tutorials that are available from the help menu in the Oasys Primer. You can visit our website for more information on trainings, webinars, and tutorials. We also offer our clients complimentary spaces on Arup delivered training courses. Register your interest on our website. If you would like to be up to date with the upcoming training and webinars and other news, the Oasys team sends out a monthly newsletter and you can sign up for that in the given link. To keep up to date with our latest news, you can also subscribe to our channels on LinkedIn and YouTube. For any questions, you can send a mail to dyna.support@arup.com or contact your local distributor. Thank you.